get started because there's a lot to go through. It feels quite fitting, actually, that this talk is after Venkat's, because his is very much about creating an architecture and about how to actually build the software. This is actually about the next step, the releasing of the system and the maintenance of the system and all the different pieces that go together with it. So this talk is continuous delivery of the missing parts, and this is very much stemming from my thoughts and processes throughout the years about actually how to release and maintain software. I have some contact details down in the bottom left. Is that any better? Yep. So there's some contact details down in the bottom left if you want to get in contact with me. I'm very bad at email, so. About me, I'm an infrastructure engineer for a cool startup. We're building a search technology, which is quite fun. I'm a reformed ASP.NET and C# developer. Sorry to any C# developers, that's not anything bad. I'm a DevOps extremist and I'm a conference junkie. I love going and talking to people about this type of stuff because this is actually what I do on a day-to-day basis. So the background to this talk, continuous integration and continuous delivery has been something that has been an interest to me for many years. From my very first day at my first job, I was thrown directly into the worst practice possible. I went into a company to work on a piece of software, and I asked my boss to give me the location of the source control, and he pointed to a machine under his desk. And he said, "That's where the software is." I was like, okay, so how do I get it off that? And he goes, "You don't. You have to remote desktop into that machine, and you work on it on that machine." This was actually for one of the medical informatics systems in the UK. This was a pretty serious piece of software, very simplistic, but pretty serious. It was actually that pharmaceutical companies would be able to bill the NHS in the UK for using their drugs. So this was a big money system. And we did some work on it, and it was pretty horrible, and we went to release it, and I said, "How do I release it?" He goes, "What you do is you take the folder from the RDP session and you FTP it to production. No compilation. The files compiled on the web server when people actually visited the page for the first time." Now, we've all had nightmare problems like this. It's just the way software works. And it's made our life very difficult in a lot of situations. But since then, I've decided that employing better practices about releasing and the management of software is very much what I will spend my time on. I have seen an incredible amount of sessions recently because continuous delivery is a newfangled thing and it's all the cool things about people saying continuous delivery the whatever way, okay, or a lap around continuous delivery, or how to get started with continuous delivery, okay. This session is a chance for us to understand what continuous delivery has been for a number of years. Continuous delivery has been around a long time. It's just probably not a term people will have heard. Just to refresh our minds what continuous delivery is, it's a set of practices, principles aimed at building, testing, and releasing software. Okay? The most important part of that statement is the "and releasing software." Okay, it's something as developers we tend not to do. We tend to be afraid of releasing software. It's a scary process. And there's some principles that go with it. I'm not going to talk about them, but there are 4 practices. The practices are very important. Okay? Build your binaries once. Do not, please, if there's anything that you take away from this talk, do not rebuild your binaries between environment QA or pre-prod or whatever and production. You must release the binaries that you've tested and that you can verify. It's very important. Use the same mechanism to deploy to production that you deploy everywhere else. I never realized how important that statement was until about 4 years ago when I started at a large US-based company. They were doing Git checkouts, SVN checkouts on QA environment, and then having a completely different release process to production. When it went to production, it was like the world was burning. Okay, smoke test your deployment. How do you know that your deployment is successful if you don't test it? You need to verify. Hands up in here who verifies when a deployment has been made. Less than half. It's not a practice we do normally. It's not something we're ever told that we have to do. So therefore, we just forget about it. And lastly, if anything fails, stop the line. Stop what you're doing immediately. Don't let your bugs creep into downstream work. If I check some crap in and cause a bug in production, I don't want the next person to have to deal with that rubbish. There's a book on this. It's a very well-known book. If you haven't read it, please get it. It's the Continuous Delivery book by Jez Humble and Dave Farley, and it was first published in 2010. Okay, July 2010. So is Continuous Delivery only 5 years old? The slides will be available, I promise you. They're already online. Okay. Yeah. Okay. Okay. So the book is called Continuous Delivery. Okay. Yeah. So Continuous Delivery was actually first talked about during the Agile Manifesto. Okay. Now we're going back here to 2001. And we had some of what we now class as some of the most influential people in the software world got together in Utah in the United States to discuss software development. Now, it included people like Martin Fowler, Ken Beck, Bob Martin, Ron Jeffries, Jeff Sutherland, many, many, many more. And the first principle that they came up with was that their highest priority is to satisfy the customer through early and continuous delivery of valuable software. This is something that's been around at least 14 years. At least 14 years. But it's only something that's become more poignant because we're in such a world that evolves so fast now. So people realize that they have to embrace this. And there are some common misconceptions to what continuous delivery is. The first one is continuous delivery is only something that startups can achieve. Rubbish. I gave these common misconceptions this morning. Number two, continuous delivery only works for Node.js or Ruby or Java or Go developers. Rubbish. If you're C# or .NET or Java or whatever language you want, you can do it. In fact, there's a whole stream of thought right now about continuous delivery for embedded systems and mainframes. You can do it. It just takes time and effort and lots of balls. Three, you can hire a consultant to help you implement continuous delivery. I'm really sorry, consultants. You can't just go into an environment and check boxes and say, yes, you're now continuously delivering. Not at all. It just doesn't work like that. Number four, you can right-click in your IDE and publish, and that's continuous delivery. Also crap. I'm sorry to say, it will get you so far. It might be great for your personal blog site. It won't do well for a system, a production-ready system. And I'm pretty much sure if you told your CTO that that's how you're deploying their production software that's costing millions of pounds, you may get yourself in a little bit of hot water. And number five, continuous delivery is not as simple as hooking GitHub up to Azure or Heroku or AWS or any of these cloud providers. Again, it may work for a blog site, not for a real production system. Best quote, until your pretty code is in production, making money, or doing whatever it does, you've just wasted your time. And this is really, I've got anyone who was in my session this morning, there's a couple of slides that are the same, and then we're going to go really far into the actual continuous delivery side. But this actually goes very much to what Venkat was saying. Just evolve your architecture. Get it into production, get user feedback, understand what it's like. One of the things I actually took away from the last session of Venkat's was when he said only 20% of software is actually used, right? So if that's the case, why do we spend so much time getting that software into production? Let's get it out there. Let's get some user feedback and understand the value of it to our customers. It's really important. Haven't I just contradicted myself? Haven't I just said that you shouldn't do really simplistic Git-based deployments and then told you that it's about getting your software into production fast? The answer is no. Because how you get your software to production is very important. Okay? But it's not as important as how you keep your software in production. Because software stays in production a long time. A long, long, long time. So you need to make sure that you've got a surefire way of always releasing that software and making sure you're not introducing risk into your system. Risk is a killer. Anyone ever heard Conways Law? So Melvin Conway basically said that in a nutshell, the more hierarchical an organization, the more hierarchical the software it can produce. Okay, yeah. So I Googled the term traditional IT company. I wanted an organizational structure, okay? And I found that there were developers and QAs and sysadmins and network and help desk and infosec and all of these other departments. I don't know why the slides aren't looking like that. It's kind of weird. But effectively what this is saying is that each of these departments have no crossover. And you can see that when you plot it on an organizational chart. Anyone work in a company like that? It happens. Like this is, what I'm saying here is if you work in a company like this, I'm not using the term you're doing it wrong. You're not. You're just not making your life as easy as it could be. This is very difficult to work in. And what do you think the software they create looks like? Who even knows? I'm sure that this person here has absolutely no idea what this person does. Because they're so far removed from each other in their systems and what they do that they don't need to interact. Aren't we supposed to be one team? By creating these layers and these silos, you're effectively stopping our systems from being as successful as they can. Now, I'm not saying that you go back to your company on Monday and walk into your boss and say, get rid of all these. We are all now the same team. We have an open plan office. We all sit beside each other and we all go for lunch and hold hands. That's not the case. What I'm saying is that it's very important that you don't just think in your tiny box. You have to think about what effect your system has on other people up and downstream. It's very important that you think like that. Because only then will you begin to ask questions like, is this the most useful way of doing this? Or is this even worth doing? Because if I know that they're not going to use it, then you can challenge people and start to say, where are the metrics based on how successful this is going to be? And if somebody comes back to you and says, well, we have no metrics or we have no idea of how a success it's going to be, then you can say, well, let's create some. Let's work out how we can find the value of that piece of software. It's all about questioning, all about trying to drive for the most value possible. I asked some people this morning this, and Mary Poppendijk, who's like, she's one of my agile heroes. I think she's absolutely incredible, I really do. And she asked the question, how long would it take your organization to deploy a change that involved a single line of code? And can you do it on a reliable, repeatable basis? Again, this ties very closely into what Venkat was saying this morning about using the frameworks and about using the libraries. And if you can't move quick in order to fix systems, then what do you do? Now, there are usually two ways of doing this. Firstly, you're told, well, if it's a bug fix, I can do it in maybe a matter of hours. Or if it's a normal production change, then it'll take days or weeks. Okay. Question yourselves as to why there are two different ways in which you release your software. One for bugs and one for normal changes. They're both code. If you can release your bugs in a matter of hours, you should be able to release your normal code in a matter of hours. And you can draw this in a value stream map, and you can begin to plot how long things take between systems. And this was actually in my last company, where there was actually 19.5 workdays wasted every month And when I plotted this for the CTO, he started beginning to question. He was like, why do we wait 4 days after a prioritization meeting until the developer actually starts the work? Why can't somebody just fix it themselves and just put it out? Or why after a developer fixes it, why is it going to a completely separate QA department? Can't the QAs integrate with developers? Let's remove those 4 days. That's madness, though. You don't want to talk. We're all in IT, and we're all introverts. We don't like talking to people. And then why does it take 4 days from when a QA has passed it until it gets ready for production? By beginning to plot this type of thing and using the measurements, then it's really easy to see how you waste your time. You're not wasting time, how your software wastes time in order to get it out into production. Go back and draw this in your company. It will really open up some dark holes, and it will uncover some serious bugs in your system. The value stream for operations is much worse. Okay? It used to take 8 weeks for a server, a VM, to be provisioned at my company. 8 weeks, because it went from the sysadmins to the networking guys, and then it went to the security people, and then it went to QA people to make sure it was ready for software to be released on, and then it went to the developers who would mess it up, and then it would have to go back around the cycle again because they didn't get the release cadence right. And it used to take a long time. When I left that company, we got it down from 8 weeks to provision a server to 6 minutes. Okay? Now, that 6 minutes was because it was a Windows environment and it took 3.5 or 4 for it to boot. So it would have been much faster. It's all about measuring. Measuring is very important. It's not all doom and gloom. Okay? There are some people out there who are amazing in the IT industry who are trying to make these things better. Okay? And this is where DevOps came in. Anyone ever heard the term DevOps? Anyone think they know what the term DevOps is? Or where it came from? So, in 2009, in California, there was O'Reilly's Velocity Conference. Okay, and you had 2 people created a talk there called 10 plus deploys a day at Flickr. Okay, and it was John Allspaw, who now works at Etsy, and Paul Hammond, who works at Slack HQ, as of when I wrote the talk a couple of months ago. And they actually talked in 2009 about how Flickr, which was a massive application that was used by so many people, and they were still doing at least 10 deploys a day. Now, this was a groundbreaking talk because John is from operations and Paul is from development. And we never thought in IT that development and operations would ever mix. We always thought that the ops guys are the people with really long hair that sleep under the stairs and eat pizza and only work at night. But they actually showed that by coexisting, they were making better systems and releasing software faster. There was lots of discussion on Twitter, and basically some people decided, let's bring a velocity conference to Europe. Okay, Europe's always left out because the Americans have lots of money, blah, blah, blah. So on October 30th and 31st, 2009, in Ghent, in Belgium, I'm told Ghent is only good for 3 things. Any Belgians here? Okay, I'm told it's only good for 3 things: beer, chocolate, and fries. I want to try all of those. I like all of those things. And then they brought some people together, developers and sysadmins, aka ops. You getting where this is going? For 2 days, and they called it DevOps Days. Okay. Flashy title, right? And what they did is every time they would tweet about it, and they were tweeting everything out, they would hashtag it DevOps Days. And on Twitter, as you've only got 140 characters, they were like, why don't we drop the days off it and we'll just hashtag it DevOps? That's actually where the term came from. It wasn't 15 management people sitting around a boardroom going, what's the new Agile? Should we call it, what should we call it? DevOps? It was just a term that grew organically from what they were doing. And because of that, there was a whole range of tools that have stemmed. Graphite, Jenkins, Sensu, Vagrant, Logstash, Chef, Puppet, Terraform, Grafana. So many more. Go and Google DevOps Tools. It's hilarious. People love keywords on Google. And there's such crazy links where you would think, is that actually a tool? If you think of it, somebody has already written a tool for it, and it's probably been given the term DevOps or continuous delivery. But what continuous DevOps boils down to is there used to be silos, the wall of confusion. Developers on one side, operations on the other. Developers actually want to make changes. Operations used to just want stability. The company I worked at, the operations people were being paid for uptime. If they achieved 4 nines or 5 nines or whatever, they would get a bonus. And if the developers could not release their software, the CTO used to say, why are you not releasing features? You're not releasing them fast enough. They were complete opposing views. Because operations wouldn't let the features out because they think, well, that directly affects my pocket. Why should I let them release it? And that's what DevOps has been tried to kill. DevOps Borat says, if you're praised for website success, you're a dev. If you're blamed when the website goes down, you're an op. Simple as that. And what happened is developers would take the package of software, throw it across a mythical wall or a silo, and the operations guys would release it. Anyone still work like this? A few. What you end up was it worked fine in dev. It's an ops problem now. Right? I asked people this morning, I said, if I gave you a USB stick that you had no idea what it was, would you plug it into your laptop? So why, as an operations guy, should I release a package of software I have no idea how it's written? Same principle. Same principle. So how does DevOps help with this type of thing? How does it help remove the barriers? DevOps introduces what's called the 3 ways. Okay. Systems thinking, amplifying feedback loops, and creating a culture of continual experimentation and learning. Okay. This is all well documented. You can go off and read all the blog posts in this, but this is a really simplistic overview. The first way, systems thinking. Thinking of moving our software from the business to our customers. Okay. It's a flow of information from left to right. Okay, you think of developers acting on behalf of the business, and you think of operations acting on behalf of the customers. And it's about releasing the software. Okay. Now, what that helps us do is understand that there are types of work. And there are 4 types of work. Business projects, so like search or UI improvements. Internal projects, architecture changes. Paying back technical debt, which is really important. Changes, everyday tasks that we have to do, changing schemas, actually releasing software because that takes time, smoke testing, etc. And then the last one, which is the killer, unplanned work. It tends to be that the unplanned work has a much higher percentage than all 3 of the other types of works combined. Because unplanned work includes things like investigating downtime issues or bugs, or when a customer or a manager comes to your desk and says, hey, that software doesn't work. Okay, let's deduce what you mean by not working. And it takes time, it's context switching, it's moving away from what you're trying to achieve. So the first way helps us understand these, and if you can help to minimize unplanned work, then you can start to top load everything else. You can then start to apply more time to business projects or refactorings and paying back technical debt. And you can start to change the balance of how you release your systems. The second way, amplifying the feedback loop. So developers have pushed some code into production and the operations guys have to deal with it. Now it just makes perfect sense that the operations team feed back to the development team how it's working. Okay? Now, feedback, it has to be proper feedback. You can't just turn around and tell someone, hey, that software you released yesterday is crap. It's killing my systems. A better way of saying it would be, hey, John, that software you released yesterday, that's actually added an extra 15% CPU to our production systems, and we've had to scale out a little bit. If you could, the next time you're in that area of code, could you start to look and see what the problem is? Okay, that's useful feedback. That's actually helping developers work out where there could be potentially technical debt in their system. Now, we should capture metrics about everything. Okay, and I mean everything. There's a company called Etsy, and Etsy have a philosophy of measuring everything. And only at the point of which they understand if it's when it's useless is when they will stop collecting it. I believe, I haven't been to their office, I believe they have a dashboard in their office that has over 100,000 metrics of information on it. I found out 2 days ago that the metrics infrastructure of Facebook is bigger than the entire infrastructure of Instagram. Okay, Facebook take billions of metric points a second because they want to know what's happening in the system. And what that helps them do is create what's called situational awareness. Now, Patrick Lightbody of BrowserMob, who was the CEO, actually said that we found that when we woke developers up at 2 a.m., defects got fixed faster. I have been on the receiving end of this. I actually have. My girlfriend has been woken up numerous times in the middle of the night because my pager goes off. And I will guarantee you that the next night that will not happen. Because the first thing I do is I will go and fix my mess, my rubbish. Because if I've put it out there, I'm the problem. I have to fix it. I have to take responsibility. It's not fair that other people get woken up from my rubbish. Okay? But you can't do that unless you gather metrics and logs around systems. The third way, as you've mastered the flow from left to right, and then the feedback from right back to left, you can then start to experiment. Has anyone ever heard of multivariate testing? Or A/B testing, as it's commonly known in some areas? Okay, so you can actually take a very small percentage of traffic in your system and direct it to a particular release. Okay, the most famous company that do this is Facebook. Facebook actually release new features to their website to 17% of the female population of New Zealand. That sounds like such a made-up metric, right? 17% of the female population of New Zealand are the first to get the new feature on Facebook. But I can guarantee you, I heard this directly from the engineering manager at Facebook, no two people in this room will see exactly the same page on Facebook. There will be tiny differences between the systems because they're continually testing things. And that multivariate testing is because they have mastered the flow of information and the metrics and the collection of information. Now, this can do simple things. At my last company, we used to do stupid things and actually test the conversion. We used to turn around and go, if I change that button from red to blue, what percentage increase or decrease on the conversion of the application would it have? And we had metrics for that. Or if I removed the rounded corners and made it work in IE7, would that have an effect on my site? And that's that continual experimentation. Because when we experiment and we learn, we can help create value faster. There are two great books on this, The Goal and the Phoenix Project. Both are pretty much the same story, just retold. One is from the 80s and the other one is from 2012. But what they teach us is that you can adopt DevOps through 4 things. They call it CAMs. Culture, automation, measurement, and sharing. Culture. People and process are the most important thing. If you don't have people who buy in to a culture, then any automation attempts will be completely fruitless. If you pay a consultant to come in and automate the hell out of your system, and your developers, your operations people don't want to use it, They won't. And it's been a waste of money. Automation. Once you have the people in place, then you can start to build the fabric of your system in order to automate it. Okay. Now, this is where we can start to stitch tools together for release management, for provisioning, for configuration management, monitoring, alerting, control, orchestration, all of these pieces. And we're going to talk about them all, hopefully, if I don't run out of time. Measurement. If you can't measure it, you can't improve. It's as simple as that. That includes people metrics. People metrics are a very interesting one. Some people believe that we should not collect people metrics. When I say people metrics, I'm not using it as a stick to beat people. I'm trying to work out if we're applying too much pressure on developers to create software. If they released 4 production bugs into the system in a 2-week period, is that because as a manager I am pushing them too hard? Is there areas in which we can improve and learn from? You should collect everything. Everything is useful. And last one, sharing. As I said earlier, IT people are introverts. We don't like talking to other people. But we can all learn from each other. We really can. One of the most important parts of a conference for me is the networking. Because I can go and I can hear stories from people who don't want to talk in front of a group of people, but they'll talk like one-on-one or between a very small group, and they'll give me ideas on how I can get better at a specific thing. Or they'll give me their war story, which will inspire me to do something else with my software. Networking and sharing is really important. That's where DevOps came from. It's because a collection of people got together to share their issues in order to make them better. Now, when I say developers and ops, I also mean other pieces of the system as well. QA is really important. Really, really, really important in what we do. Okay? Because those are the special people who actually find bugs where developers can't. There's something just in a QA that'll always find something. And then you've got business people. If you've got an IT organization that has transformed, but your business is still stuck in the 1960s and how they do things, and how they walk up to your desk and bypass any process, then you're probably not going to be very happy. We're all part of the same team. Really, we are. And if you're not inside your company, and you don't feel as though you're inside your company, find another job. There are many, many, many jobs. In fact, give me a call and I'll get you to come to London and I'll introduce you to a whole load of companies. So many people are hiring right now. Anybody in here work for companies that's hiring? 1, 2, 3, 4, a few. But that's the thing, there are so many available jobs. If your company is crap and they don't want to adopt this, leave. Don't put up with it. Go and be better at what you do. Evolve your career as much as you evolve your architecture or your software delivery. You're as important as any piece of software. Metrics and automation are key. Absolutely key. If you don't collect metrics, you have no understanding of what's going on. When you adopt these principles, you can achieve the technical side of your IT organization post-DevOps. Okay, now, again, I gave this slide this morning, and it's basically around, this was from a talk last year in London, October, by John Turner of PattyPower.com. And what he basically said is his entire IT organization are actually involved in every piece of this. Not directly. This isn't a case of developers actually working in production and so on, but it's all a collaboration. It shows that it's one map, that they're all working off the same page. Okay. The reason it looks like a tube system is he gave the talk in London, so he was trying to be quirky, and he's from Ireland, so you have to forgive us. And what that actually does is it brings us to, well, as developers, we used to be the people that would create the build systems. We would be the people that would go into Team City and configure builds. But the operations people have a big role to play in this as well. And there is the continuous delivery side of ops. And these are the missing parts. These are what, as software developers, we forget about. Configuration management. Anyone use a configuration management tool? The minority. Okay, so you got tools like Ansible, Salt, Chef, Puppet, CF Engine. I'm not even going to say the Microsoft one. You've got the DSC now, which is really good. These are all tools to help us manage our systems. Okay, they will provision our systems. You will declare the state of a system, and the tool will keep that system at that maintained state. Okay, it's a declarative way of doing it, and they've been very successful throughout the years. There is a movement now known as Mutable Infrastructure, in which there was a talk in a blog post in 2013 by Chad Fowler, who works for 6 Wunderkindle. So they create Wunderlist, the to-do app. And what he said is, he said you should trash your servers and burn your code in mutable infrastructure and disposable components. Okay. Has anyone ever heard the term Snowflake and Phoenix? So a Snowflake server is a server that has been in production for a long time. It is manually maintained. You have a group of people who will SSH in or RDP in, and they will install packages. You cannot guarantee that when you rebuild that server, it will come up in the same way. It's classified as a Snowflake. And what Phoenix servers are, is servers that are maintained by like configuration management or much more immutable, and you can trash it at any time, bring it back up, and you will guarantee that it's the same. Now, I have a job that runs in a tool. Hopefully I've still got access. Good. And it checks, can't see it. It basically goes to AWS every single night, and it tells me all the machines that are older than 14 days. Okay, so it's going off and it uses just a pure AWS call. And what it does, on 14 days, it will destroy it. And it will rebuild it. Because it doesn't matter if it's 1 day, 2 days, 3 days. I have to have the system pieces in place that will allow me to rebuild stuff. Do you know what? Let's destroy some of my production infrastructure. Sorry? I'm not. I work at a startup. We don't release software. So what this script is going to do, it goes off to AWS, takes the autoscaling group name, finds out all the instances in that autoscaling group, and one at a time, in a HA manner, it will destroy the box and recreate it. Okay? Sorry? This is production. Oh, I'll change the name of the app. The app is actually called Demo. Okay. Let's actually call it Admin API. I probably could. I'm not here to show hacking. Hacking is bad. But in actual seriousness, let's destroy it. And let me go to the instances, just so that you can actually see that it destroys instances. Doesn't matter. They're users. Users that, if you have load balancers, they'll change across and stuff like that. I have a load balancer in the front. Users won't see any change. None. I will get paged right here if they do. I actually will have my phone. Just in case, I will be paged, okay? If there's any downtime. Sorry, it's really slow here on the internet. Here we go. So there's a machine there, okay, in Ireland. And it's the same admin API. And if I run the job, I'm not going to wait for the job to finish. You'll see the notification come through because it takes like 6 minutes or 7 minutes. Okay. And what it's doing, just in a nutshell, it finds the list of instances. It will increase the capacity by 1 to take it to 2, and then it will take the old one out. So it does it in a completely HA manner. Okay, and if I actually go across here and refresh, you'll see another box is spinning up. And we'll check in on it again in 5 minutes. Okay, but I can guarantee now that that box will be exactly the same as the one below it. Exactly the same. Is the tool automated? No. It runs every night, every morning at 7 a.m. UK time. Yeah. But what it does is it will trigger a job and say, oh, those 4 auto-scaling groups have got boxes in them that are too old. Let's just destroy the whole lot and just recreate it. And this is much more of an immutable infrastructure, because I can guarantee that there's no state held on any of my boxes, and that they can all be brought up in the same way, and I have 7 minutes to do 20 slides. Awesome. But the immutable development world, the immutable programmers actually took offense to this, and they were like, but it's not real immutability, because there's always going to be some level of state, like log files or session-based stuff in there. So Mark Burgess, who's like one of the most famous people in the DevOps world, said, why don't we call it disposable infrastructure? It makes much more sense, because it's meant to be disposed. Another tool, logging. Anyone have central logging tools? Anyone use Kibana, Splunk, Logstash? Lots and lots and lots of tools. No? We deploy every single log that goes through our system goes in via Kibana. Everything. And we can search based on type. And we can see basically when specific applications are more active than others. And we can see that, look, yesterday at 12:34, which is the start of this green box, that's when the new boxes came into effect, because we've recycled the whole system. And we can begin to understand what's going on everywhere. Really important. There's one of my metrics, or logging and metrics talks online about how to build a logging infrastructure. So at my last place, we were taking 1 billion metrics a day, 1 billion logs a day through our system. And it talks about how to use like a stream-based system in order to pull the metrics through. And you end up with an architecture. This is just my old logging infrastructure, and it looked like that. It was about 118 machines just for logging. It was awesome. It was my baby. I loved it. And then we could create graphs that looked like that. This was actually one of the development team's graphs, where they worked out that based on tags that went through the logging system, their applications took 22.4 million hits a day. And out of that 22.4 million hits a day, 70 of them through non-200 requests. So they could work out the percentage of errors in production, because they knew exactly what was happening. And you probably won't see it because of the bad screen. There's little tags right here and here, and that's actually marking where a deployment happened in the system. So they could work out when the CPU rose after a deployment and when RAM rose after a deployment. So everything was being measured. It's really important to measure everything. Metrics themselves, that was just application metrics. These are the system metrics that you can get. Server requests, you can do network requests, you can do CPU, RAM, blah, 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 whatever. That's using Grafana. Okay, it's a free tool. All of these tools are all free. You don't have to pay for any of them. You just have to take the time in order to make things better. Okay? Monitoring. Anyone do monitoring? System monitoring? Alerts? Yeah. I used to use Nagios, and I could write really descriptive Nagios checks that looked like that using Puppet. Okay, I wouldn't use Nagios anymore just because I think it's quite old and it doesn't have a nice UI on it. Everyone loves a UI, right? And what I do now is I can write my checks in YAML, because we've all moved on from JSON and we've all gone to YAML now as developers. And this is using Ansible, so these are the same style of checks written in a different way, and we can check processes at a specific type or a command or a specific interval, And then we can do things based on it, whether we want to subscribe to certain events or etc. Monitoring and alerting and logging are arts. They are as difficult to do as actually creating the software. If you learn them, you will guarantee that your system won't even be able to sneeze until you know about it. Orchestration. I showed you a tool that I was doing that last demo with called Runback. Okay, Runback is another free tool. But Runback allows us to orchestrate jobs at the same time all the time in the same way. What I mean by that? Let's check on this job, by the way. Okay, we can see, oh, there we go, look, the instance has come up. It's reached the desired capacity of 2. It will now deregister the old one from the load balancer, and then you'll see another message in a second saying, destroy it. Jobs. So I have a number of jobs that happen all the time. Okay, for example, with Elasticsearch is a memory hog and it's a disk space hog. I have a job that runs every night that deletes old indexes and closes old indexes. It's an orchestration across a number of servers all the time. Okay, I actually can restart Kafka clusters, restart Elasticsearch clusters. I can. These are my favorite ones. Every night I orchestrate security tests against my system. I will actually try and hack my own public systems every night. And these tests will run in 16 hours, 41 minutes. And if I go and have a look at the recent, you will see a lot of them passed. But there are some that actually failed. Maybe. Possibly. Ah, there you go. So we actually had production vulnerabilities at specific times using specific ports and specific hosts. Okay. Orchestration allows us to do this again and again and again in exactly the same way. Think of orchestration as like a style of cron job or a style of scheduled task. All right, what have I got? Awesome, 1 minute. Data center as code. I can destroy my entire production data center and migrate it across to a different region in AWS, and it takes 6 minutes. We actively practice this. Actively. And it just uses like really simple declarative DSL functions, and it will actually draw our system integration diagram. And I was going to give a demo, but I've run out. But what this effectively does is this gives us disaster recovery built in. I am destroying my system and re-bringing it back up every time. I don't need a disaster recovery scenario because everything is 100% automated. The most famous people that do this are Netflix. Anyone ever heard of the Simian Army? So Netflix have 3 tools in there, or at least 3 tools in their Simian Army, should I say. Okay, you got Chaos Monkey. These are brilliant. These are the best names. They're absolutely amazing. Chaos Monkey is a piece of software that they will randomly deploy into their environment, and it will just destroy boxes. In the same way as my system is doing it. Okay? Only it doesn't use Runback to do it. It actually uses Chaos Monkey, and they will actually simulate outages and make sure that their systems can all come back up. Okay? You've got Chaos Gorilla. AWS has regions, and inside regions there's availability zones. So the closest for you guys here will be EU Central. And EU Central has 2 availability zones, 1A and 1B. And Chaos Gorilla will actually simulate what happens when the availability zone 1A or 1B goes out. Will their system still function? Okay. And then you've got Chaos Kong. Okay. Chaos Kong will actually simulate an entire region going out. Okay. If they lost US West 1 tomorrow, what would happen to the Netflix system? AWS had a massive outage a couple of weeks ago in US East 1, and Netflix had no downtime whatsoever because they failed across to US West 2 instantaneously. They just failed over. That's good disaster recovery. That's not waiting on somebody, waking somebody up in the middle of the night and getting them to drive to a data center in order to reboot a machine. That's not disaster recovery. There's a whole continuous delivery maturity model on InfoQ. You can have a look. Basically, the more to the right you go, the better it is, and you can practice it and get it. And if you're a if you adopt continuous delivery and DevOps, then you're better at what you do, and you can move faster and release software better. The most important thing is continuous delivery in DevOps means better software and better products for your customers. Customers are both internal and external. Do not let your poor customers inside your company suffer of bad software either. Any questions, come and find me, or tweet me, or send me an email. Thank you all very much. It's been a pleasure to speak here.